If math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping. Hello, hello. Today we have Mr. Witt in the house. We have Aspect in the house. We have Janae. We have Justin Norwood in the house. What's going on there? Justin is eating eggs and grits while watching Mr. Witt. Angry Hermit is in the house. Let's give everybody a little taste of the super chat here. All right. Hello, 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 everybody. Good to see you guys. Good deal. Yeah. Here we have part 2 of the Intermediate Algebra Final Exam Review. Aspect is saying, Mr. Witt's going on. You were going on, Aspect. Thank you for joining us again. Empress is in the house. Good morning. Ajalon is in the house. What it do? How you doing? Good day. I got my orange juice on deck. We're good to go. That's right. We're good to go with a little bit of the orange juice. And yes, you're right, Aspect. Arrows will be popping. Jesse's in the house. What's going on, Jesse? Poly King is back. It is arrow time. You are absolutely correct. Ronnie Coleman style, says Aspect. Man, it's good to see you guys today. I really am excited. I have a fantastic part 2 of the Intermediate Algebra Final Exam Review for you guys. And just to remind you guys, how you doing, Charmaine? Good morning to you. That today's lesson will be a continuation of Math 0312's Intermediate Algebra Final Exam Review Part 2 from Fort Bend Tutoring. Mr. Witt in the house. And we're going to have a good time. And we're definitely going to get some arrows popping today. Jesse has his red pen ready. Exactly. Oh, man, I can't wait, guys. I cannot wait. Let's go ahead and dig on in. Angry Hermit says, I'm not in the house, but I'm staring at you through the window. That's what's going on. That's what's going on. Got that long distance peeping Tom thing going on, Angry Hermit. Very good. Good to see you. Let's get things underway, guys. Let's get things underway. Here in number 21, it says to perform the indicated operation and expressed in lowest terms. So this is what we're going to do here. We're going to first of all recognize that when you are subtracting rational expressions, you are subtracting fractions. And what do we need when we are adding or subtracting fractions, guys? We have to have an LCD in play. We have to have at least a common denominator in play when we are adding or subtracting fractions, aka rational expressions. So this is exactly what we're going to do. Notice that these two terms already have a common denominator. Oh, yeah, they do. The common denominator is already in play. So all you have to do is combine the numerators. And the way I'm going to show this, let me show you how I'm going to show this here. Let me get my black ink ready. And so we have 3x plus 10. Here we go. Let me get my lie right. Minus the quantity of x plus 6 all over my common denominator, which is going to be x squared minus 2x minus 8 in the house, guys. That's what's going on here. So because we already have a common denominator, we can go straight ahead and subtract. That's right. The two numerators. But notice what's going on, Chosen Creeper. But notice I just took my time with it. You see what I'm saying? And I went ahead and said I'm going to subtract the quantity of x plus 6 from the 3x plus 10. I'm just taking my time. And because we're already ready to go, guys, we're going to get our arrows popping as I distribute that negative in front of that set of parentheses. Amen, amen. And I will go ahead and write this as 3x plus 10 minus x minus 6 all over my common denominator of x squared minus the 2x minus the 8. Oh, yes, I am. And then we're going to combine some like terms around here. That's exactly what we're doing. So remember, you have like terms as long as the terms have the exact same variable with the exact same exponents on that variable. And we have that case right now. So we'll have the 3x minus the x. That gives us 2x. Oh, yes, it does. We have 10 minus 6. That gives me 4. positive 4 all over my x squared minus the 2x minus the 8. And I believe we may need to go ahead and add another page here. Let's do just that. Let's go ahead and add another page to this. Oh yeah, look at all my problems I got ready for you guys today. Look at all the problems I have at the ready for you guys today. Let's go ahead and hook this up. So we had our x squared minus our 2x minus the 8 in the denominator here. Let's go ahead and grab that real quick like. There we go. Getting things started with problem number 21, picking up from the last problem we did in part 1, which was problem number 20. Thank you very much. So with this 2x plus 4 divided by the x squared minus 2x minus 8, what we'll be doing now is factoring as much as possible. We got Jenny in the house. Jenny from our class is joining us today, guys. That's right. Jenny Trevino. What it do, Jenny? That's right. Let's go ahead and hook that up real quick where everybody can see that Jenny has joined the super chat. All right, there it is. There it is. And as always, guys, Chosen Creeper says, come on with that blue box. We'll see what we can do right now, Chosen Creeper, in just a second. So as always, guys, go ahead and share the stream. Go ahead and like that sucker. Go ahead and subscribe to FBT. We have K Boudreaux is in the house. All right, K Boudreaux is in the house. What to do, K Boudreaux? So factoring the numerator, we're going to factor out the GCF of 2. Okay, we got 2 in the numerator we can factor out. So factoring out 2, that gives us 2 times the quantity of x plus 2. In the denominator, we're looking for 2 factors of 8 that will subtract to give us 2. That'll be 4 and 2. So I have x minus 4 times x plus 2. And when you are simplifying your rational expressions, guys, Angry Hermit says you could draw a cube instead of a square for once. I think I may combine Chosen Creeper's request with Angry Hermit's request over here in the super chat as they're trying to get me to draw a blue box and also draw a cube around the answer. All right, we'll see what we can do. We can combine those together, guys. All right, so with that being said, we are going to go ahead and simplify our rational expression by canceling out our x plus 2's to give us a result of 2 divided by x minus 4. And we are going to blue box our answer. And matter of fact, for Angry Hermit, we're going to go ahead and make that a perfect cube right there. There we go. We have, what's going on, J Fantasy? We have our answer in a blue cube today, ladies and gentlemen, as requested. We have Alexis is in the house. What's going on, Alexis? Good to see you in the live chat. Good to see Fantasy in the chat. Good to see Jenny in the chat, as all 3 are my students at Houston Community College. Amen, amen, guys. And I got people from around the globe joining in today. I appreciate that, guys. So y'all appreciate that, huh? Y'all like that? Look at that. We got people impressed with the blue cube today. So y'all are already starting with the challenges, man. What's going on? Fantasy was a request. That's what's going on. That's what's up with that. At what HCC do I teach, Jesse? I teach at the Spring Branch campus. That's at I-10 and Bellway 8 near Memorial City Mall. Angry Hermit says, I think it's a classic cube. You got that right. Because I'm a classy kind of guy, and Angry Hermit, you better believe it. You better believe I'm a classy guy. Let's go with problem number 22. All right. Look at me making an upgrade, guys. Look at me making an upgrade on that live stream where I can include the live chat on the screen for you guys. All right, there it is. Jesse says he's transferring to Spring Branch ACC campus because he's only 15 minutes away. That's what's up, Jesse. Come join your boy. Fantasy says he can dig it. Got to make some more shirts now. Already, man. And since Fantasy brought it up, go ahead and get your Forbidden Tutoring t-shirts. We got a link. There you go. We got a link, guys, in the description box. That's what's up. Let's get back to work. We got people trying to study for their final exam reviews here. In problem number 22, it says for us to multiply. We had a quantity 7 minus 5i times the quantity of 7 plus 9i. And they want us to give the answer in standard form. When they are referring to standard form, guys, they're referring to A plus BI form, where you will put the real number before the imaginary number. That A value must be a real number, and it must come before any imaginary number that you have in your answer to complete that complex standard form. The standard form of a complex number is a plus bi. Okay, so that being the case, let's go ahead and bring down our problem here. This 7 minus 5i times the 7 plus 9i. There we go, guys. And we will be getting our arrows popping. Just to let you know, we are going to be getting our arrows popping. Oh, yes, we will. I'm going to go ahead and circle this negative term here just to make sure I'm reminded that I'm going to distribute a negative value in that second stream of arrows that I have popping over there. And we have 7 times 7 is 49. Oh, yes, it is. We have 7 times 9i is going to be 63i. We have negative 5i times 7. That gives me negative 35i. We also have negative 5i times 9i. And this gives us negative 45i squared. Amen, amen. Oh, yeah. Dealing with some imaginary numbers here. That's exactly what's going on. And so with this, we'll be bringing down our 49. We can combine our middle terms here. Let's go ahead and get a little subtraction going on here, making sure I have my subtraction right. Y'all go ahead and make sure that you're checking my work here. I'm going to need to borrow from the 6. That gives me 13 minus 5. That gives me an 8. That gives me a 2. I end up with a positive 28i minus 45. And guys, did you know that I squared is equivalent to negative 1? Well, it is. Yes, it is. Oh, yeah. And so now we have 49 plus 28i plus 45. Okay, so it looks like I need to add. Okay, so adding my like terms here, my 49, all right, plus the 45 here. Let's go ahead and add that together. We got the 14, carry that 1. We end up with 94. So our final result here in standard form for a complex number is going to be 94 plus 28i. I hate that 8. Let's fix the 8. There we go. 94 plus 28i, and we will red box it, ladies and gentlemen. There we have it. Problem number 22 is in effect. Done and done. Yeah, there you go. That's that answer for problem number 22. We had to keep in mind that our value of I, let's go ahead and bring a little green ink in here, that our value of I squared is equivalent to negative 1. And that substitution was made right here. So we went ahead and substituted that value of I squared with negative 1. At this point, went ahead and multiplied the negative 45 times the negative 1 to get a positive 45. And you must write the real number before you write any imaginary numbers that you have. And how am I doing so far, guys? Is everybody understanding me well? Can you hear me clearly? Give me some feedback, guys, in the chat. Give me some feedback in the chat. There we go. Let me know how I'm doing. We have problem number 23, guys. We have simplify with the quantity negative 3x to the 9th power times negative 2x to the negative 4th power is what we have. All right. So with this problem, we'll be multiplying. We'll be simplifying here. And don't you know, Fantasy says that we have it popping. We had Mr. Norwood there saying that the arrows were popping. Aspect machine guns going off everywhere. There we go. Imaginary numbers beyond imagination already. There we go. We had a little delay, guys. We had a little delay with the super chat, but we are back on point now. Angry Hermit says, okay, I got it. Thanks already. Good stuff. That's right, Chosen Creeper. That is right. That I is the square root of negative 1. That is correct, Chosen Creeper. Good job. Boudreaux says everything is all good. Fantastic, K. Boudreaux. Good stuff. That's right. Mr. Diaz is in the house. What's going on, Lewis? All right. Hey, Lewis, did you get your winning Adonit Jot Pro stylus yet? All right. Did you get that stylus in the mail yet? Because we sent you one. So thank you for joining us today. One of our contest winners is in the house, also moderating. Good job. Let's go ahead and multiply things out, guys. Here we have a negative times a negative. Thanks, Jenny, for the thumbs up, letting me know everything is perfectly loud and clear. And a negative times a negative giving us a positive, all right? And we have 3 times 2, which is always 6, guys. And when you are multiplying like basis, you will add the exponents. That's exactly what you'll do. You'll add those exponents here. And so when I'm adding 9 and the negative 4 together, 9 minus 4 is 5. I mean, this problem did not have a chance. It is dead. Oh, you just got killed by Mr. Witt. Let's go ahead and put you in a red box there. You know what? We're gonna put you in the yellow, and we're gonna put you in that yellow chalk. There you go, outlining that dead body. That's what we're gonna do. We're gonna outline that dead body because this problem thought it had a chance against us today, but it didn't. It's dead. It had to go. That was problem number 23. We are enjoying some math today, guys. We are reviewing for the intermediate algebra final exam. That is what Jamila's in the house. What's going on now, Jamila? I can't do this without you. Let's look at problem number 24, guys. We have solved the system for x, and when it comes to solving a system of linear equations in intermediate algebra, you have the following things that you've been brought to your attention. That's right, aspect. Dead bodies are everywhere. We got a cleanup crew, which is you. That's right, aspect. We got a war zone up in this piece. Exactly. You have been introduced to the substitution method. You have been introduced to the elimination method, and you've also been introduced to graphing a system of linear equations in order to solve for the solution of that. And you know what? In order of preference for Mr. Witt. That's right, Justin. It's been assassinated. In order to solve a system in my preference, guys, in order for this class, is the elimination method as number one. That's my favorite. That is my favorite. The substitution method would come next. And last but not least, we have the graphing method, which I cannot stand as a method for solving a system of linear equations. You know what I'm saying? I'm just being honest with you guys. Oh, yeah, I'll show you how to do it, even if I don't like it. But I'm just letting you know what I prefer. The elimination method is top dog as far as my preference for this class, guys. And so because the elimination is my preference here, we're going to attack this system by eliminating the y variables. That's right. Now, if you're going to use the substitution method, guys, I would suggest that you solve for the second x. That x in the second equation is what you should isolate, and then plug that result back into the first equation. If you're going to use the substitution method, there you go. And Angry Hermit is already going to hook you guys up with the link for solving a system of equations using the substitution method. There you go. Lewis already has the answer as 3/8. All right, let's check that out then, Lewis. So what I'm going to do is I'm going to multiply this first equation here. I'm going to go ahead and rewrite it, guys. I have my 5x minus 2y equals -1. I have my x plus 4y equals 35. And I'm going to show that I'll be multiplying each and every term in this first equation by 2. That's right. By using the scalar 2, I can end up with additive inverses on my terms that contain the variable y. Let me show you what that looks like. We'll have 10x minus 4y equals -2. And I'll keep that second equation exactly as it is. Oh, yes, I will. I'm going to keep this second equation exactly as it is. Doing so, thank you, Angry Hermit, with the link. Good stuff. We're going to be able to cancel out those additive inverses for those y's. They cancel out. 10x plus x gives you 11x, and this equals to positive 33. From here, we'll be able to divide 11 to both sides of the equation. You end up with a value of x that equals to 3. Oh, yes, you do. So we have 3 as our value of x. Now, when it comes to solving for y, guys, what's going on? Sarwan and Sorry, how you doing? Good to see you today. So at this point, guys, we'll be plugging our value of 3 back into one of the original equations. So I'm going to plug it into the second equation, I believe. And just to let you guys know, if I can get my words together here, you can plug in this value of 3 into either of the original equations. It doesn't matter which one you do it in. I'm just willy-nilly here. I'm just flipping a coin, and I'm saying, okay, I'm going to plug it into the second one. So plugging my result of 3 into the second equation, I can rewrite that as 3 plus 4y. This equals to 35, and then subtracting 3 to both sides here. Okay, you'll have 4y equals to 32. You'll divide both sides by 4, and your y value equals to 8. The y value equals to 8. Live here. Sorry, guys. Let me go ahead and hook that up there. There you go, so you can see it. Sorry about that. Now you can see it. Okay. Yeah. So what we did was, once I got my value of 3 for x, I went ahead and plugged that value into one of the original equations to end up with the result for y, and we plugged it back in. What's up, David Laguna? How you doing? And so now as our solution, because your solution is a point of intersection between two lines, you need to write your answer as an ordered pair. So that means you need the parentheses. You need to write the first value, which is your x value. You need to write the second value as your y value, and then close those parentheses to write your result as an ordered pair. And then we are going to red box it. Let's get this red color together. Red boxing the answer as an ordered pair. We have what's going on here? We gotta go ahead and look at a question here. It says you can do it that way too, right? Let me see. I just bring down that 5 down to a -5. Let's see. Bring down the 5 down to the -5. Where are you bringing down the 5? Oh, bring down the 5 to a -5. You're bringing down the 5 to a -5 and then canceling it out. And that's the way Patrick JMT does it? I'm not sure about that. I mean, are you talking about just injecting a negative? He may do that if your other term is a positive 5x aspect. And I do respect the work of Patrick JMT. He needs to holler at me one of these days. Patrick JMT does, because he's from Texas as well. He's in Austin, and I'm in H-Town in Houston. Yeah, but Patrick JMT is an excellent YouTuber. Yes, he is. But for this particular problem, we would not be injecting a -5x unless we make the second equation. If we multiply the second equation by -5, then you can cancel out the x terms aspect. So maybe that's what you're referring to. All right. But just to let you guys know, especially you aspect, you must put that 3 before the 8 when you're writing your answer as an ordered pair. All right. Because the x value has to go first. It has to come first. Amen. Amen. Also, Polar King says you can eliminate whichever you want. Right, it does. All right, now you can choose to eliminate the x terms or the y terms. Okay, so that's where your freedom is in play. And when you decide which term you're going to cancel out, that generally aspect determines what value you'll need to multiply by. So for instance, if I chose the x's to eliminate, I would have multiplied the second equation by -5 in order to end up with additive inverses on the x terms. But since I chose the y terms to cancel out, all I had to do was multiply the first equation by 2 to end up with a -4y. So the point of me eliminating the y variables in this case is because I am lazy. Let's not get mistaken about myself here. I'm lazy, so I'm going to always pick the smaller number, the smaller LCM between the variables here. So if you look for the LCM, the least common multiple for the x variables, it would be 5 in this case, whereas the LCM, the least common multiple for the y's, is 4. So 4 is going to win over 5 for me any day because it's a smaller number. So I always will pick the variable when using the elimination method. I'm going to always choose the variable that has the smallest LCM, the least common multiple, because I am dealing with smaller numbers when necessary. Absolutely. Because there'll be less stress on me. Okay. So that's all I'm doing. All of these things that I'm showing you guys is just showing you how to manage your stress. That's it. Now, if you like big numbers, you go for it. I'm going to always choose the small numbers when it comes to solving math problems, guys. And let's move on to our next problem. But good questions, guys. Look at y'all getting involved with your good questions today. Let's go ahead and bring you back up. We have problem number 25. It says find the slope and the y-intercept of 4x minus 5y equals 5. That's what we have here. Once again, we are finding the slope and the y-intercept of the linear equation that is given to us in standard form. Remember that standard form. Let's go ahead and hook you up with the standard form here. Standard form of a linear equation is ax plus by equals c. That's supposed to be a c there. Let's fix that c. There we go. That's an ugly c. Better c. There we go. Had to hook up that better c there. So recognizing that they are giving us the equation, the linear equation in standard form, we are going to write our equation here. We're going to rewrite this in slope-intercept form. Why slope-intercept form, you may ask? Well, it's because they literally asked for the slope and the y-intercept. That's why. And that's why we want to hook that up. We want to hook it up because they are asking for the slope. They are asking for the slope of the line as well as the y-intercept, which is where the line crosses the y-axis. So that's why we'll be putting this in slope-intercept form. Amen, amen. All right. So we'll start out by subtracting 4x to both sides here, guys. Oh, yeah. We'll be bringing down the -5y, which equals to -4x plus 5. And then we'll be dividing each and every term by the coefficient of our variable. All right. So we're going to divide each and every term. There we go. There we go. We're going to have that as -5 being divided to each and every term there and simplifying that. All right. So there we go. Now, Wilka Low. Okay, let me say. We got Wilka Low Kaliki. All right. I think that's a reference to a song or something because I've seen that name before, but sorry if I mispronounced it. As when you're eliminating, don't you have to divide? It depends on the problem. Yeah, it depends on the problem. But most of the problems, I'm going to multiply the entire equation by. But yeah, there are some cases where you can divide that. Yeah, absolutely. You can do that. So it depends on your problem, whether or not you divide or multiply. It's up to you. Okay, but your goal is to get additive inverses, opposites of either the x or the y terms. And that is a question referring to the previous one. So that being the case, guys, let's go ahead and simplify this. We'll end up with y equals to positive 4/5 x minus 1. Now that we have it in slope-intercept form, which is, by the way, let me go ahead and hook this slope-intercept form up for you guys. You have y equals to mx plus b. Now that you have that in play, we can identify that the slope of the line, which is m, for this equation is going to be 4/5. All right, that is going to be your slope. Okay, and then when we have our b value, aka the y-intercept, that value is -1. And that's it. That answers the question. It says to find the slope and the y-intercept of the line. We have it. And we will be red boxing it. Absolutely, guys. Red boxing it. So let's see here. Yeah, so Lewis has it correct with the slope of 4/5 and a y-intercept of -1. Aspect says, when do you flip slope? Okay, gotcha. You flip the slope aspect when you're dealing with a perpendicular line. You flip the slope and change the sign when you have a perpendicular line that you're referring to or that you're trying to create. That's when you use the opposite reciprocal. That's when you flip it and change the sign when they are requesting the perpendicular line slope, or they're requesting you to write a line that is perpendicular to the given line. That's when you find the opposite reciprocal. What's going on, John Smith? What is going on with you? Up in today's final exam review for Intermediate Algebra Math 0312. That's right. Let's check out number 26, guys. We're going to keep it moving today. Get you some problems in. Per Mr. Witt and Fort Bend Tutoring. We have problem number 26 where it says simplify by reducing to lowest terms. Guys, we are going to factor completely. Oh, yes, we are. And then we're going to simplify our like factors. That's exactly what we're going to do. All right, Treasure Ghost is in the house. What's going on, Treasure Ghost? All right, the myth, the legend has arrived. Treasure Ghost. Let's go ahead and show Treasure Ghost some love, guys. Let's go ahead and show Treasure Ghost some love and make him a moderator. That's what's going on. Showing Treasure Ghost some love since he is the legend, Treasure Ghost. That's right, John Smith. We're going to factor it first. That is exactly what we're going to do. So, starting out, we will start by factoring out the GCF of 4 in the numerator. That gives us 4 times the quantity of x plus 1. In the denominator, we will also factor out the GCF of 4. That leaves you with 5x squared plus 7x plus 2 in the denominator. Let's go ahead and extend that fraction bar there. Once we have this, guys, we can simplify this by canceling out the 4's. All right. And in the numerator, you'll still have your x plus 1. And in the denominator, we will go about the business of factoring the 5x squared plus 7x plus 2. So let's go ahead and get ourselves a little sidebar action here. So what I'm going to do on this side here is I'm going to go ahead and take that 5x squared plus 7x plus 2, and I'm going to factor it. What's going on, K Mills? How you doing today? And so in factoring this, I'm going to use the AC method that I prefer. So that means I'll be multiplying 5 times 2 to give me 10. That massive product there, and looking for factors of 10 that'll add to give me 7. Well, that'll be the same 5 and 2 that I used to get that product in the first place. So I'm going to open up 2 sets of parentheses. I'll have my variable x. I'll have the number 5 and 2, those factors. The sign of the middle term must be the sign of the largest factor. And since I'm adding, the 2 must also be a positive value. And then I'll be going back and dividing by that leading coefficient, which in this case is 5. Simplifying this, you'll have x plus 1. Any remaining denominators will go in front of the variable. So you'll have 5x plus 2, and this completes the factorization of 5x squared plus 7x plus 2, and I'll place that in the denominator. So we have, let me go ahead and get my black ink back, guys. There we go, since I'm not in the sidebar anymore. So here I have completely factored the denominator. I have completely factored the expression. I've already simplified that GCF of 4 that I brought out. And the chosen creeper says, good thing I still remember the AC method already. It comes in handy, doesn't it? So in the numerator, x plus 1 goes into itself once. X plus 1 goes into itself once. And we end up with a result of 1 divided by 5x plus 2 in the denominator. And this is our result for problem number 26. And we have red boxed it. That's right. Jamila says I have a pre-cal, that you have an AP or a pre-final exam. Oh, okay, gotcha. You have a pre-final exam for beginning algebra on Monday and Tuesday. Well, some of the things that you see in this here video, Jamila, should help out just fine. And keep in mind, our pre-algebra video for the beginning algebra could be either the first final exam that we did a couple of weeks ago, that is called Basic Mathematics Final Examination, and also you can check out the one that we did on the Foundations of Mathematics. That should also help you for that final exam, and some of what we do today, of course. Aspect says, my teacher in college has never seen the AC method that I do. Once you get to the dividing part, yeah, she said, what the heck? That's right. This is the way Mr. Witt rolls. That's right. Many teachers have not seen that method done. Oh yeah, so I like to share and share alike. John Smith has the answer. That's right. That's right. Chosen Creeper come with the different ways to write the answer. He says that it could also be written as 5x plus 2 raised to the negative first power. But keep in mind, Chosen Creeper, that we do not leave negative exponents on our answers if given an opportunity. There you go. That's what's up. Aspect says that his teacher's way was way too complicated. I understand. I like to keep it simple. T-Hay, what's going on? We just had some barbecue for winning the algebra test. Congratulations, T-Hay. All right. That is awesome. Good job. Congratulations there. Let's look at problem number 27, guys. Looking at problem number 27 here. So we are going to simplify the complex rational expression. We're simplifying the complex rational expression here. And in order to take care of this complex fraction, guys, because we have multiple terms in the denominator, I'm going to use the method where we will multiply the numerator's terms as well as the denominator's terms by the overall LCD. That's right, the overall least common denominator is what I'm going to use. So the overall least common denominator, guys, is AB. That's right. AB is what's going to be distributed to each and every term. In other words, I will be getting my arrows popping in the denominator as well as multiplying that AB times the numerator as well. All right, so let's go ahead and get ourselves some room here so we can get to business. So distributing the AB, guys, this AB is technically over 1. All right, so when I multiply the 9a squared minus 25b squared divided by AB times AB, all right, you could, let me see here because I already see the questions coming. Let's go ahead and hook this little area over here so I can get some slow motion up in this piece. Let's get a slow motion going. Let's say that I have the 9a squared minus 25b squared divided by the AB. It's going to be times AB over 1, guys. All right, so this is what I'm referring to. Okay, so what happens here is that the ABs will cancel out to leave me with 9a squared minus 25b squared. All right, and that is a hot mess over here. Let me fix it because it's a hot mess. I know it looks ugly. We're going to fix it. There we go. A little plastic surgery there. So once we've done that, your numerator is now just going to be 9a squared minus 25b squared, because we eliminated that AB by multiplying that term by the least common denominator of AB there. Okay, now I'll be multiplying 3 over b. All right, once again, let's hook up this legible writing here from Mr. Witt. We have 3b times AB, which is over 1, right? So when I multiply this out, guys, one of the b's will cancel out to leave me with 3a. So we end up with 3a in the denominator minus when negative 5a is multiplied by ab, a similar effect happens. The a's will cancel out this time to leave me with 5b. So once again, each and every element of my rational expression was multiplied by the LCD, the least common denominator, which was AB. And this was the least common denominator of all of the fractions, not just the denominator. I included that denominator in the numerator, which was the AB. Okay, but notice in the numerator, guys, we have a difference of squares. So because we have the numerator of the form a squared minus b squared, we can use our factoring pattern for that, which is a plus b times a minus b. In other words, we're going to factor this numerator and end up with 3a plus 5b times, let's fix that b, let's fix the b, let's fix the b, get that b fixed. There we go. We have 3a minus 5b all over the 3a minus 5b here. And so what happens is that 3a minus 5b is going to get canceled out. Let's go ahead and take this to another page here, guys. I'm getting a little cramped over here. Let's go ahead and hook this up. I'm getting a little cramped over here. Okay. So let's go ahead and add a page. Let's add a page in here. Get this hooked up, so we can continue our problem. There we go. So here we have our previous step where we completely factor the numerator, which was a difference of squares. And just referring back to that difference of squares, guys, let me go ahead and give you the formula for that. If you have an expression in the form of x squared minus y squared, a perfect square minus another perfect square, then the factoring pattern for that will be x plus y times x minus y. And because I'm an optimist, I like to put the plus sign first. That's right. So who in the chat puts that negative sign first? Okay, because you need a lot of hugs because you're a pessimistic person. All right. So get off that. Leave with that positive first. So that's why I have a positive first in my numerator, where I have the 3a plus 5b times 3a minus 5b. But if you're a person like Angry Hermit, you're probably going to put that negative sign first. But I think Angry Hermit says that she likes to put the positive sign first too. All right. So even she has a shiny side to herself. All right. Good deal. All right, good stuff. Jamila says that she has checked out all of the videos on algebra and they were all very helpful. Thank you so much, Jamila. Hope you do well on your test. Make sure that you have mastered as much of the content as possible. Chosen Creeper says, so the numerator is the square of the denominator. So the answer is the denominator with a different sign in it. Not necessarily, Chosen Creeper. No, they're not equivalent. It's not the same thing as having 3a minus 5b squared. There are two different values. All right, but they do share a common factor. All right. No problem. What's going on, Abina? How you doing there? Aspect says, my teacher does the negative first. Really, Aspect? A teacher that puts the negative sign before the positive? Really? That is saying a lot about your teacher. All right. I would definitely get her checked out. Polar King says, I try to do the positive first. I forget half the time, because half the time, Polar King, you're not positive. Check your mood, Polar King. All right, so we're going to cancel out we're going to simplify this, guys. The 3a minus 5b's, they'll go into itself once. So you'll technically end up with 3a plus 5b over 1, and anything over 1 is itself. So your answer here is 3a plus 5b. That's right, the positive 1 in this case. And we end up red boxing our answer here, guys. That's what's going on. All right, so guys, what I want you guys to do is to make sure that you are sharing the stream with the people that you love, and especially the people that you hate. Go ahead and show them some love too, and let them know about the stream that we're reviewing, Intermediate Algebra Final Exam Review today. All right, there you go. And she's the head of the Intermediate Math Department too. That's, oh man, that is crazy. The coordinator? Nah, man, don't tell me that. Don't tell me that Aspect. So here we're going to be simplifying here. We have a rational exponent in play. That's right, T.A. We're going to red box that. Mr. Shep is in the house. Thanks for the love there, Mr. Shep. Good to see you today. So, yeah, make sure, guys, that you are sharing the stream with your people. Go ahead and like the stream, of course. Click that bell notification next to the subscribe button, and you'll be notified when we are live with our final exam reviews or any other math topic that we're doing live that day. All right. And of course, subscribe to the YouTube channel Fort Bend Tutoring. And if you're able, go ahead and show some love by donating to Fort Bend Tutoring. You can use the super chat, that little $sign at the bottom of that super chat there next to that smiley face that you see there in the super chat window, guys. You can click on that symbol to use the super chat right there at the bottom there. Right down her. You see that down there, the little $sign. You can go use that to do the super chat, or you can find a donation link in the description box. Either way, guys, and that will go a long way to helping us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. Well, here's the deal, guys. What we should be recognizing in this problem is that our index, the denominator of the rational exponent, is 3. That's letting you know that you will be dealing with finding cube roots and simplifying cube roots. So if we go ahead and show, for instance, that we have in the numerator here that we have 3 cubed, in the denominator we have 5 cubed, we can go about our business of distributing the exponent on the outside here. Now, because our base is negative and because we have an odd exponent, you will end up with an odd result. Okay, so that's perfectly fine to take the cube root, in other words, of a negative base. That is okay. You won't be able to do that if that denominator had been an even value. So if you were trying to take the square root or the 4th root or the 6th root, if that denominator was an even number, then this would not be a real number. Okay, so what we can do, because it is okay, so it is legitimate to take the cube root of a negative base, then I already know that my answer is negative. All right, and that's a long negative sign, so I'm gonna go ahead and trim that down there, trim those bushes, those edges there, and get that together. All right, so let's get off of landscaping. So we'll multiply the exponents now. Okay, and so that's the case, and we'll end up with 3 to the negative 2 power. Okay, and the way we got that is by multiplying 3 times negative 2/3. The 3's canceled out, so we'll end up with 3 to the negative 2 power. Then multiplying that 3 in the denominator on that base of 5. What's going on, Poly King, with the $5 donation? Y'all better respect Poly King. Y'all better respect Poly King up in this piece, guys. Respect Poly King with the $5 donation. That's right, immortalized on the final exam review. That's right. Way to go, Poly King. That is the second time you donated, man. I really appreciate the love. And this is your love right back, Poly King. We letting the world know about you and your generosity. Thank you so much, sir. That is mad respect. Thank you. We love the people that just don't talk to talk. They walk the walk with the actions. Just like I'm putting in work right now, Poly King. You're putting in work as well. Appreciate you. Poly King is in the house, guys. Respect that man. So here we'll end up with 5 to the negative 2 power in the denominator. And now what we're going to do, because we have negative exponents on our bases now, we'll be able to shift those bases, the 5 going to the numerator, the 3 going to the denominator, to end up with a negative 5 squared divided by 3 squared. And so now, evaluating those values now, you'll have a negative 25/9 as your answer, guys. And we will red box it. Let's go ahead, and that's right, Poly King has a challenge, guys. Poly King with the challenge to you guys. Poly King says, who wants to match that donation? What's going on, Dan? How you doing? That's right. Let's get this final exam popping, guys. Let's keep these donations going. If I get my words together, let's keep these donations going. Let's go ahead and keep this final exam review going. Appreciate that, guys. Let's keep this rolling now. And so to recap for Poly King, let's get his name on the screen a little bit longer. We had our quantity of negative 27 1/25, and guys, because it is raised to a negative 2/3 exponent, the denominator of the exponent tells you what is the driving force of the problem, that you're looking for perfect cubes here. All right. And because we're looking for perfect cubes, we're going to show that in the form of rewriting 27 as 3 cubed, rewriting 125 as 5 cubed, and then multiplying the exponents on that. Aspect has a question, guys. He says, Mr. Witt, I thought we had to put all of that over 1 since the exponents were negative. You could have put all of that under 1 if you wanted to, but then that would have created a complex fraction. So that is a possible way to solve the problem aspect. But as you see, I didn't have to do that. And I wouldn't want to do that in this case because we were already dealing with a fraction. And then if you shifted that to the denominator, then you would have ended up with a complex fraction, which for some people would have made it more complicated. Okay, so aspect, you can use that by placing all of that under 1 because they had negative exponents. But a different way is to shift those bases that have different exponents to change the signs on those exponents. All right, good deal. Okay, so once again, you had to get rid of the negative signs, all right, on your exponents, but the base that's negative remained negative. So keep that in mind. Okay, keep that in mind because we start out with a negative base, and it's okay to take the cube root of a negative. The end result of that will be negative. Then keep that in mind. All right, good deal. So once again, ladies and gentlemen, let's go ahead and give some mad respect to Polly King is in the house, and we will be moving on to our next problem. Problem number 29 is in the house. Polly King getting it started with today's donations. All right, good stuff, guys. We have problem number 29. We're going to solve negative 7x plus 3y equals 2, and we're going to be solving that for y. We'll be solving that for y. And that means we're just manipulating the problem here. We just want to isolate our variable y. And that's it. That's it. That's all they want us to do, just to solve for y. So let's get to it. So we'll be starting out by adding 7x to both sides of the equal sign, like so. We'll be bringing down 3y, which equals to 7x plus 2. Once we have this, all you have to do now is divide each and every term by 3. That's exactly right there. So dividing everything by 3, we have y equals 7/3 x plus 2/3. All right. Done and done, ladies and gentlemen. And Obina, you could write it that way. That is correct. So Obina is showing, guys, that you could also write this result as the quantity of 7x plus 2 all divided by 3. That is another way to write the result. However, I prefer the first way because it's akin to slope-intercept form. So I'll have more usage out of the first form, even though the equivalent form, Obina, is what you have, which is the 7x plus 2 divided by 3. They're both equivalent results. So in other words, they're both the right answer. So as far as solving for y, we have our result here as well as here. There we go. We red boxed them both. So they are both the correct answer. That's right. Obina, I did have the slope-intercept form, but your answer is correct as well. But I just personally like to have math students write their result in slope-intercept form because it has so many uses. Okay, so there are times where your form of 7x plus 2 divided by 3 would be useful, but not as much in a math class as having it written in slope-intercept form. So it's always good to be able to practice that as much as possible because you get so much use out of it. There's so many times that you're going to do that. All right, Dan says, do I have calculus videos? Yes, I do, Dan. Look in the calculus playlist on our YouTube channel. All right, and Angry Hermit is going to be nice enough, hopefully, to go ahead and put a link to the calculus playlist in the super chat, and you can see the link for that, Dan, for the calculus videos. Now, to be honest, there are not that many calculus videos on the channel just yet. My passion is algebra, so therefore I'll have I have many algebra videos when compared to the other main the main sciences of math, like calculus and trigonometry and geometry and stuff like that. The majority of the videos that you'll find on Forbidden Tutoring are algebra based because that's what I like. But I will be making more calculus videos and other videos in the near future. Dan, but thank you for your question. Let's move on to our next problem here in this review, in this final exam review. Thanks, Angry Hermit. You are an awesome moderator. Much respect to you, Angry Hermit. So we have in problem number 30. Oh, hold on. Let me get this orange juice break here. Excuse me. Dan is saying awesome, and thanks so much to Angry Hermit and Mr. Witt for providing him with the calculus playlist. Our pleasure, Dan. Our pleasure. We are a team. We are a unit. Mr. Witt and the moderators, M and M, coming on down the stream. We have the live stream. That's right. Red boxing it all day, every day aspect. You better believe that. Here in problem number 30, it says to solve the following equation, we have x divided by 2x plus 2 equals negative 2x divided by 4x plus 4 plus 2x minus 3 divided by x plus 1. What you want to be aware of, guys, in doing a problem like this rational equation, is you want to be aware of all the factors that are in play within the denominators. So we're going to start out by factoring completely. That's what we'll do. So I'm going to show that the denominator, this first denominator, is basically 2 times x plus 1. That the second denominator here is 4 times the quantity of x plus 1. And of course, we obviously have x plus 1 in that last denominator. What I was doing that for, why I factored all the denominators, is because if I can multiply each and every term by the least common denominator, I can eliminate these fractions in this problem, and that's exactly what I want to do. So let's go ahead and make some room here by taking away the chat for a second, and we'll go ahead and multiply each and every term by 4 times the quantity of x plus 1. All right, and I'm going to show that I'm multiplying this times each and every term. That is what I'm doing. So each and every term will be multiplied by that LCD, which is 4 times x plus 1. All right, and I'm doing that to each and every term, trying to squeeze it in here, guys. That's what I'm trying to do. Trying to squeeze it in here for you so that you can see what's going on. So this is Mr. Witt multiplying each and every term by the least common denominator of all the terms. All right, amen, amen. All right, so once I have this, guys, you should be able to notice that the x plus 1s will cancel out in that first term. 2 will go into 4 twice here. Okay, so I'm ending up with 2x. Then I have my equal sign, of course. In the next term, the first term on the right side of the equal sign, the 4s will cancel out. The x plus 1s will cancel out. So I'm left with negative 2x. Then plus my x plus 1s will cancel out, so I'm left with 4 times the quantity of 2x minus 3. And this is what I have after I've multiplied each and every term by our least common denominator of 4 times x plus 1. Let's go ahead and grab this and take it to our next page here. All right, let's go ahead and copy that. And do I already have a page waiting on us, guys, for problem number 30? Yes, I do. I predicted I needed another page on this one. All right, so there we go. Let's go ahead and hook this up. I'm losing it, guys. Here we go. Let's hook that up. Let's put it right there. Kill that, and here we go. All right, so what we did, first and foremost, we multiplied everything by the least common denominator. Aspect says, can't you just set that LCD to 8 times x plus 1? You can use that aspect, but it is not the least common denominator. So you're contradicting yourself. The least common denominator is the first multiple that they have in common. And the first multiple that they had in common was 4 times x plus 1. Now, is 8 times x plus 1 a common multiple? Yes, it is. But it's not the least common multiple. It's not the least common denominator. And that's what I used in that problem. You will get the same answer if you use that, but it would not come out as clean as if you were to use the least common denominator. So the least common denominator comes in handy because, like I said before, I like to keep my numbers small. Your values would be 2 times mine, it would be twice as large as mine, in other words, if you use that 8 times x plus 1 instead of the 4 times x plus 1 aspect. That would be the difference. And as I told you before, lazy wins with me. So here, I'm going to get my arrows popping, ladies and gentlemen. So I'm bringing down the positive 2x here. Let me get my lie right. We'll have 2x equals negative 2x plus 4 times 2x is 8x. 4 times negative 3 is negative 12. And then we will be combining our like terms here. Negative 2x plus 8x gives you 6x minus 12. From here, we'll be subtracting 6x to both sides of the equal sign. Oh, yes, we will. We'll end up with negative 4x, which equals negative 12. That's right. Then, okay, we'll be dividing both sides by negative 4. So therefore, your result here is x equals 3. But you need to make sure that that 3 does not create an undefined situation in your original problem. In other words, this 3 could be an extraneous result. So checking back on our original problem for number 30, notice that numbers like -1, all right, the value of -1 would have created an undefined situation. So that is why we had to avoid that value. In other words, -1 was not in the domain of this original equation, so it could not be a possibility for a solution. And that confirms that 3 is just going to be fine, okay? It won't create zeros in any of those denominators. Therefore, our answer to this problem is 3. All right, let's check and see what you guys are over here talking about in the super chat. All right, so therefore it says then you would have to refactor. Right. So they were talking about simplifying that problem aspect, right? And then we have take the path of least resistance in math. That is absolutely what I love to do, Angry Hermit. And then John Smith said, could you put it into a cube root of 3 squared? A cube root of 3 squared. I'm gonna go with, where did that cube root of 3 squared come from, John Smith? Cube root of 3 squared? Are you talking about a square root of 3 squared as far as being funny with the way you're writing your answer, John Smith? You can put it into a square root of 3 squared, and that'll give you the answer of 3. All right, if you wanted to be fancy with your answer. I don't know if your teacher would be happy about that. So I'm going to go with no on that question, John. All right, for that particular problem. Obina says, even that, is that even rational? Hey, Lewis, you cannot use 2 times the quantity of x plus 1 because 2 won't go evenly into 4. I mean, well, 2 goes evenly into 4, but 4 won't go evenly into 2. That's why the LCD of that last problem was not 2 times x plus 1, Lewis. It had to be 4 as the least common denominator. It has to be a number that they can all go into evenly. All right, there we go. Done and done. So, yeah, that was number 30. We're doing good, guys. We're doing good on our time today. Let's get through some more of these problems here, okay? So in problem number 31, we have solve for y. We have -7y minus 12 is less than or equal to -8y minus 5. And we want to graph the solution set. All right. And when they're referring to graphing the solution set, they're referring to graphing the solution set on a number line in intermediate algebra. All right. So let us start by solving for y. So we have our original inequality, which is -7y minus 12, which is less than or equal to -8y minus 5. And when it comes to inequalities, guys, I always solve for the variable on the left side of the inequality. That is right, because it just makes the graph that much easier. It makes my solution that much easier, okay? It makes my interval notation that much easier. It makes my set builder notation that much easier to solve for the variable always on the left side when I'm dealing with an inequality. So that's exactly what I'll be doing. Oh, yes. So that means I'll be starting out by adding 8y to both sides of the inequality here, using the addition property of equality. There you go. And I'll end up with y minus 12 is less than or equal to -5. Then adding 12 to both sides here. You'll end up with the result that is y is less than, not 17. Oh, no, Mr. Witt, 7. Let me get my lie right. Thank you. That's right. Correcting it on the spot. Y is less than or equal to 7, guys. So this is the solution of the inequality. However, they requested the graph of the inequality. So let's hook up this graph real quick. So with my graph, I have my number line here. And the most important number on my number line, guys, is the number I'm referring to, which is the number 7. Okay? So on this, I'll be starting out by using, in intermediate algebra, we use the brackets and parentheses on our number lines. It's not the open and closed circles when you're dealing with intermediate algebra. It is right next to college algebra classes, getting you prepared for college algebra, where we use interval notation. So in intermediate algebra, we use brackets and parentheses instead of open and closed circles on our number lines. So because it's less than or equal to, we'll have a bracket at 7, and because the values that are solutions to our problem are to the left of 7, meaning that they're less than or equal to 7, we'll be shading to the left. We'll be shading to the left. So this is the graph. That is the graph of our linear inequality. Yeah, there you go. That's what's up. That's the answer. And as always, we will red box it, ladies and gentlemen. I hate that box. Let's fix it. Let's fix that box there. That box wasn't too box-like. That's a better box. There you go. Angry Hermit, why are you flipping the table? What happened on that problem? What happened? Did I lose you on that one? All right, let's do a recap. First of all, because I know that I'm dealing with a that's right aspect, we are red boxing it. So in problem number 31, we're asked to solve this inequality here and graph the solution set. Well, I prefer to put the variable on the left-hand side when I'm dealing with the inequality. So we added 8y to both sides, right? We then added 12 to both sides. And then we have our result, which is y is less than or equal to 7. So because we have our variable on the left side, the inequality symbol is actually pointing in the direction that we should be shading. That is one of the perks of solving your variable on the left-hand side when you're dealing with an inequality. Notice that because my inequality symbol is pointing to the left, I'm also pointing to the left here in my shading on the number line. That's right. Jamila says you remember more of what you learn when you are calm. That's right. Polar King came with that box. There it is. Let's move on to the next problem, guys. Hopefully that helped out Angry Hermit. All right. So it says the problem was fine. I just like ruining things. No, Angry Hermit. That is a lie because you are doing so well in moderating this live stream. You don't like to ruin things. You just say those type of things. You like saying them, but you don't like to do them. Here we have problem number 32. It says to perform the indicated operation and express in lowest terms. That's right. You got it. So here, Angry Hermit is sharing some of her study tips, and she says it also helps to sleep after studying. Interesting. Aspect says, Mr. Witt, I'm going to have to go to Carvel to get us all a big cake. Tell him to make one with a big red box on it. Red box cake. That's all good. Angry Hermit is admitting that she's all talk. That's probably because you don't socialize with people, because you're a hermit, Angry Hermit. All right, so let's start out in this problem by identifying our least common denominator, because we're adding rational expressions, aka fractions, and if we're going to add these together, we must have a common denominator, and that's right, we want to have the least common denominator. And so when looking at our values in the denominator there, that 10, the coefficients there, the 10 and the 14, I know that the first number that they will go into evenly is 70. All right. And then as far as your variable and their exponents are concerned, when generating the LCD, you'll need the variable with the highest exponent that's shown. So our highest exponent is 2, right? So therefore, we'll need our highest exponent in our common denominator to be 2 as well. So our LCD for this problem is 70x squared. And I hate this 2 down here. I'm going to fix it. I hated that 2. This 2 sucked. Okay, we got to get rid of that 2. That's a better 2. That's a much better 2. That is a cute 2. What do you guys think about that 2? I think that 2 is really cute. All right. So I'm just saying, I think that 2 is just off the chain. So just letting you know. Okay, so now that I have my LCD, guys, whatever I had to multiply my original denominators by in order to get the LCD of 70x squared is what I'll need to multiply the numerator by. So since I had to multiply, not make, let me get my lie right. Since I had to multiply the original denominator by 7x, that's what I'll need to multiply the numerator by. So 3 times 7x gives me 21x here. Obina is saying something. All right, doesn't matter what. Irrational expressions is more like it. No, they're not irrational in this case unless x is an irrational number. Oh, you say they're irrational because you hate them? You'll be fine. That 2 is overpowered. Hey, exactly. Thank you. Recognizing the superiority of that first 2 right here. When I rewrote that 2, I did a good job. There you go. I just wanted you guys to recognize that. Polar King, yes, he hates him. You don't have to hate him, Polar King. All right, because much like myself, they love you. All right, so don't hate them. Don't have that. Get that hate out of your heart. In our second denominator, we had to multiply that value by 5. So we need to multiply the numerator by 5. So we'll end up with 45 in the numerator. Okay, so we can now combine the numerator and the numerators together, okay, because we're adding. And you know that when you add fractions, you keep the common denominator. So you'll end up with 21x plus 45 all divided by 70x squared. Now, you are responsible for simplifying your result, guys. So the question is, if I factor in the numerator, will I be able to simplify that with anything in the denominator? Well, our numerators, GCF, greatest common factor, is 3. Yeah. Will 3 simplify with anything in the denominator? Absolutely not. So you know what? We're going to red box this. This is the answer, guys. You can't simplify this any further. Can't do anything with that. Red boxing it. That was problem number 32. We are moving along, guys. We are getting some problems done today. In problem number 33, it says to find the x and y intercepts, then graph the equation. That's right. Jamila says we're going to be put some pop and arrow in that red box on that cake. That's right. Y'all are really doing a good job coming up with that, visualizing that cake there. All right. So the numerator is not independent. Independent of what? I mean, they're working together to make a quotient. All right. So, is it independent as far as simplifying? No, because you can factor the numerator chosen creeper, but unless it cancels out with something in the denominator, it's just going to be the same result. So the whole point of it, of factoring at that point, would have been to have an opportunity to simplify the rational expression. But since it didn't cancel out with anything in the denominator, we left it the way it was. All right, good stuff. All right, so here we have problem number 33, guys. And one of the methods, okay, to find the y-intercept is to plug in 0 for y and solve for x. One of the methods of solving for the x-intercept is to plug in 0 for y and solve for x. So let's go ahead and start for solve for the x-intercept first. That's what we'll start with. And as I stated, in order to solve for the x-intercept, you can plug in 0 for y and solve for x. Okay, so this is me, Mr. Witt, showing that if I replace y with 0, we'll end up with 3x equals to 18. Dividing both sides by 3, you'll find that your x-intercept is 6. So, as an ordered pair, you can write it as 6, 0. Okay? That's what's up. Arun, how you do that? Where did you get the question? I just joined. Hey, the question is right here at the top, Arun. All right. It says to find the x and y intercepts, then graph the equation. And also the question came from a compilation of several final exam reviews that we are using to guide us through our final exam review today for intermediate algebra room. So thanks for joining us. Good to see you. All right. And as a reminder, guys, once again, share the stream with your people that you love, that you hate. Also, like the video. Go ahead, subscribe to the YouTube channel for Fort Bend Tutoring. Click that bell icon next to the subscribe button, and you'll be notified when we go live. And if you're like Poly King, you can also donate to Fort Bend Tutoring, to help us in our endeavors of educating the world for free. That is right. So support our efforts, guys, and we will support you. That's right. It is symbiotic. All right. Let's symbiotic. All right. I think I said it right. All right. You guys will check me if I didn't. All right. So anyway, so there you go. All right. So far we've solved for the x-intercept, and we will go on to the y-intercept, guys. And so for the y-intercept, all right, thanks, Arun. And so for the y-intercept, we're going to plug in 0 for x and then solve for y. So we will rewrite this as 3 times 0 minus 18y equals 18. This gives us 18y, which equals to 18. That's a negative 18y, by the way. And then dividing both sides by negative 18, you'll get a value of y. That is negative 1. So as an ordered pair, this would be 0, negative 1 for the y-intercept. All right. Once we have this, let's go ahead and plot our points and graph the line. So let's go ahead and make some points in red. All right. So starting out, we have our x-intercept, which is at 6, 0. We have our y-intercept, which is at 0, negative 1. All right. So let's go ahead and get that point there. And connecting those points on the graph, it'll look like this. Oh, that is ugly. Let's fix it. Oh, that's ugly. Let's fix it. Oh, that's ugly. Let's fix it. Oh, that is horrendous. That is horrendous. We're gonna fix this. We got to fix it. I got to take my time with this. Come on, guys. Come on. Let me fix this because this is horrendous. Okay, that's gonna be the best I can do. That's better though. There we go. We got arrows on both ends. It's a line. I need a ruler. Yes, I do. Hopefully not for punishment, Polar King. So there we go. There we go. We have, or edge a piece of paper. Okay, well, I'm doing what I can here, sir. All right, so we're going to make it happen the way we can. So it is as good as it's going to get, but we definitely have our points identified. Jamila is laughing out loud. We have our points identified, the X-intercept, the Y-intercept. We have a line going through it, and that completes problem number 33, guys. It completes problem number 33. Let us move on, okay? And look at all of these words I had to write out. Why is it so long? I'm definitely taking an orange juice break, guys. Definitely taking an orange juice break. Oh, my goodness. It's too much. Obina says, Mr. Witt says, oh, that's ugly, erases. Oh, that's ugly, erases. Oh, that's ugly. I had to get it right, Obina. Oh, my goodness. Let's get back to this problem. We have problem number 34 in our final exam review. It says to find the slope of the line through the given pair of points, if possible. All right. Based on the slope, indicate whether the line through the points rises from left to right, falls from left to right, is horizontal, or is vertical. And the points given are -7, -9, and -5, -8. Let's take a look at it. So, Polar King asks, do I like orange soda as well as just the juice? I like them both, Polar King, but orange juice wins way over orange soda. Okay? Way over on the soda. But let me see. Let me give us some shout outs to Sunkiss. I like Sunkiss orange soda, Polar King. I also like Fanta's orange soda. Probably in that order. All right. Angry Hermit says soda increases your risk of cancer. Angry Hermit, God, man, we're going to all die. I mean, get over it. All right. So here we have our next problem. It adds pulp in it. That's funny, Chosen Creeper. So now, in order to find the slope, guys, let's get this working right. That's right, Aspect. We have our slope formula of y2 minus y1 divided by x2 minus x1, as Aspect points out. And Obina has our answer of 1/2. Let's go ahead and label. We'll go ahead and label these points first. We'll have x1, y1, x2, y2. All right? And then I'll plug in my values into this slope formula here. So we have -8 minus -9 divided by -5 minus -7. Combining those signs, you'll have -8 plus 9 divided by -5 plus 7. This simplifies to give us a slope that is 1/2. Because our slope is 1/2, guys, we are to answer the question whether or not the slope will be rising from left to right, falling from left to right, if it's horizontal or if it's vertical. Well, the answer to this problem is that our slope will rise from left to right. That's exactly what we'll do. And the reason why I'll do that is because it is a positive slope. We have a positive slope, therefore it will rise from left to right. If the slope was negative, it would have fallen from left to right. If it had a slope of 0, it would be horizontal, and if the slope was undefined, it would be vertical. So our answer is it rises from left to right. All right, and Obina was correct. Good stuff. Amen, amen. Let's go ahead and move on to our next problem, guys. That's right, problem number 35 is in the house. Polar King says, I should have brought you some Appleton orange soda back from Iceland for you. Good stuff. Man, I would have drank that, man. I would have shown you some love, Polar King, and drank that orange soda for you and got closer to cancer, as Angry Hermit would say. All right, so with problem number 35, that's right, up 1 and 2 to the right, Aspect. That's correct. Good job on that slope. We have find g of a minus 1 when g of x equals 3x minus 3. Remember, we are dealing with function notation in problem number 35. And with this function notation, you need to keep in mind that anytime you see g of x, h of x, f of x, that is just substitution for the variable y. That is only substitution for the variable y, that they are interchangeable, that g of x is interchangeable with the variable y. However, when they do give you substitution, they can give you some operations to do, such as this. They want us to replace all the x's in this equation with the value a minus 1. So let's see what it looks like. So when generating our value, our function, with the substituted value of a minus 1, we'll end up with 3 times the quantity of a minus 1 minus 3. Then simplifying this, notice how the left side stays the same throughout this whole process. We'll just keep that label, that y value of g of a minus 1 alone. We'll go ahead and distribute, get our arrows popping, thank you, with the 3a minus the 3 minus 3 here. And then we will be simplifying our result. So simplifying this, we'll have 3a, and then a negative 3 and a negative 3 will give us negative 6. All right, Obina says she has to go. You take care, Obina. Thank you for chiming in today. So we'll have 3a minus 6 as our result here, guys. And we are going to red box it. That's right. Red boxing it. That's what we have. That's our answer. So Chosen Creeper, I have to go ahead and correct you on that. That the 3's didn't cancel out. They combined. They were like signs. All right. So like signs add, and you keep the signs, so you end up with negative 6. So that was 3a minus 6 as the result for g of a minus 1. And that completes problem number 35, guys. Yeah. That wasn't bad at all, was it? Not bad at all. So that was another example of function notation. Amen, amen. All right. So, an aspect says you don't factor it out, you leave it. Yeah, you leave it just like that, aspect. It needs to be just like that. You didn't have to factor out that common factor of 3. You can leave it just like that. All right, so problem number 36, it says to simplify this. Now, in this problem aspect, you will be factoring a lot. Oh, yes. So here we have a rational expression. They're asking us to simplify it, and we will factor completely first. That's exactly what we'll do. So in the numerator, our GCF, our greatest common factor in the numerator for a squared minus 2a is going to be a. That leaves us with a minus 2. All right. Then in the denominator, you have a difference of cubes. So factoring out this difference of cubes, guys, we'll have a minus 2, which are the cube roots of a cubed and 8, times the quantity a squared plus 2a plus 4. And all of that is in the denominator there. So that is the factorization. That is me factoring the difference of cubes in the denominator and factoring out the GCF in a squared minus 2a in the numerator. All right. Once we've completely factored, as we have done so far, you can cancel out these a minus 2's. Yeah. A minus 2 goes into itself once. A minus 2 goes into itself once. Keep in mind that this quadratic trinomial here, when factoring a difference or sum of cubes, will always be prime. You will not be able to factor it with real numbers. Okay, so that being the case, we can't factor that trinomial any further. So your answer here is going to be a divided by, let's go ahead and hook that up. We'll have a divided by a squared plus 2a plus 4. And this is our answer for problem number 36, assuming that all the values of a are positive. There you go. There you go. Let's go ahead and red box it. That's what's up. There is the answer. So for those of you that needed practice on your factoring in the numerator, check out our video for factoring out the GCF. And also in the denominator, check out our video on factoring a difference of cubes. There you go. There you go. So Lewis is in the house. Aspect said, good thing I said that, because he said he was tempted to factor that quadratic trinomial. In other words, Aspect, there weren't two factors of 4 that added to give you 2. There aren't two factors of 4 that will add to give you 2. That's why that's not factorable. It is tempting to factor because it looks like a perfect square trinomial. I know, Aspect. That's why I always try to stress to students that do not try to factor that with real numbers. It is not possible. Not at all. All right, so that's problem number 36, guys. That is problem number 36, and we're on our way. I love the fact, Lewis, that I'm able to now put the live chat right there on the stream, man. I'm getting better, Lewis, with your help. Thank you so much for that tip on focusing the webcam. You are priceless. Your information was priceless. Problem number 37. We have the perimeter of a rectangle is 44 meters. If the width were doubled and the length were increased by 8, the perimeter would be 76 meters. Angry Hermit with the link for the greatest common factor. Thank you so much, Angry Hermit. You're on point as always. The perimeter would be 76 meters. All right. And then it says, what is the length of the rectangle? All right. Good stuff. Aspect says, all right, I won't screw that up on the final. I've got this. Yes, you do, Aspect. You're going to do just fine on your final exam. Just make sure that you're mastering the content that you learn in this stream. That's right. That means you need to practice on your own and make sure you're getting it right prior to taking your exam. All right. So you use us for the guidelines as for the steps to take to solve it. And then you practice it and perfect it on your own. Okay. That's the way this works. It takes work to master the content. So let's look at this situation, guys. Let's say that I have two rectangles. Okay. Because diagrams are going to do so well. Aspect wanted to chime in one more time, guys, and say that he got a 96 on his factoring test a couple months back because of me and the videos that he found on Fort Bend Tutoring's YouTube channel. My pleasure, Aspect. I am so proud of you with that 96, man. That is wonderful. Let's say, guys, all right. There you go, Chosen Creeper. Get that paper. All right. So we're going to label this first. And we're going to say that, let's go ahead and use X and Y's. Let's say that the length on our original rectangle is X. And let's say that the width is Y. It then goes on to say that if the width were doubled, meaning that we have 2X, and the width, oh, no, the width was doubled. Let me fix it, guys. If the width, which is Y, okay, if the width were doubled, all right, so the width is going to be 2Y. There you go, because I said my length was X. All right, if the width was double and the length were increased by 8, so this is going to be X plus 8. There we go. There we go with the labeling. Had to fix it, guys. I had to make it better. It's all good. Aspect. Happy to help out. Once we have this, now we can set up some equations to solve this problem. All right. So here it is. Let's remind ourselves that the perimeter here for our original equation, for our original rectangle, is 44 meters. That the perimeter of our new rectangle is going to be 76 meters. And what we'll do now, guys, is we're going to take this on a ride. All right, this nice diagram that you guys helped me with. All right, let's hook this up. All right, in the house, Mr. Witt in Fort Bend Tutoring, helping out those in need with their intermediate algebra final exam reviews with a word problem. How about that? What they aren't telling you in this problem, guys, is that the perimeter of a rectangle, okay, and let's just put the generic formula up here, that the generic formula for a perimeter of a rectangle is 2 times the length plus 2 times the width. All right, so that's one form of it. Okay, so I'll be utilizing this, all right, using my labeling that I have in my on my diagrams here to set up two equations here. So the first one I'm going to write like this. I'm going to say that I have an equation that reads 2x plus 2y equals 44. So I'm showing that 2 times the length plus 2 times the width has to equal the perimeter that is 44. That's the first rectangle. Whereas after they change the dimensions of the rectangle by doubling the width and by adding 8 to the length, that we could write an equation that reads 2 times the quantity of x plus 8 plus 2 times our new width, which is 2w. This must equal to 76. Okay, so we're going to now get our arrows popping. Oh, yes, we will. And rewrite this equation, the second equation, like so. We'll have 2x plus 2y equals 44. We'll also have 2x plus 16 plus 4y equals 76. So this is what we have so far. Let me go ahead and wipe my screen here, guys. Keeping it clean for you guys there. And looks like we need another page, huh? Let's go ahead and hook us some pages up. Let's get another page on this. Get this together, guys. Let me get this together. All right, so let's go ahead and carry this over here. Solving our system of linear equations at this point. Let's go ahead and copy that. Paste it in place. All right, so we have multiple steps in solving this problem, guys. So we'll end up, once again, with our 2x plus 2y. This equals 44. We're going to combine our like terms and, no, we're going to rewrite this is what we're going to do. Yeah, we're going to rewrite this. Hold on. Yeah. We're missing the 76 over here. There we go. How did I forget that? Oh, it disappeared. That's what happened. Okay. No problem. I got it. All right. So that equals a 76. So in the denominator there, we would be subtracting 16 to both sides. That's what we'll do. Okay. Get our life together. So we'll end up with 2x plus 4y. This equals to 60. All right. So here is our system of equations. And guys, I'm going to use the elimination method. I'm going to multiply the entire second equation by -1. This gives us 2x plus 2y equals 44. And we'll end up with -2x minus 4y equals -60. Once I have this, our x's will cancel out. We'll end up with -2y equals to -16, right? And then divide both sides by -2, and we'll have our original width being equivalent to the number 8. Okay, so that's our original width. Let's go ahead and see what our question asked for. Okay, so let's go back in time a bit. And they wanted to know the length of the rectangle. Well, let's go ahead and plug this in to solve for x then. So we'll be plugging in our value of y equals to 8 into, let's say, the first equation in order to solve for x. So let's go ahead and make some room for that. And let's get that going here. So knowing that, and let's go ahead and put our value of y in a purple circle. Okay, so beware of the purple circle, guys. Okay, beware of the purple circle. So now, plugging this 8 into the original equation here, we'll have 2x plus 2 times 8. This equals 44. We'll have 2x plus 16 equals to 44. We'll then subtract 16 to both sides of the equal sign here. You'll have 2x equals, we'll have to borrow here. That'll be 14. That's going to be an 8. That'll be 28. We'll divide both sides by 2. So the original width, the original length, is what they were requesting there, is going to be 14. And this is what we're going to red box. All right. And we need to make sure we have our unit of measurement in play, guys. So what was that unit of measurement for this? It's meters. Okay. So make sure you have your unit of measurement as part of your answer. So the answer is 14 meters. I hate that M. I hate that M. That M can fly. We'll leave that fly. We'll let that fly. All right, so the original length of the rectangle is 14. Lewis, you have the exact coordinate correct, sir. Your x and y values are correct, but as an answer is incorrect because that's not what they asked for. They only asked for the length of the original rectangle. So make sure, guys, that you're focused on the question at hand when answering application problems, aka word problems. That's right. Aspect says machine guns popping. All right. There you go. I tossed in a grenade. Here you guys go. There you go. So you can read what Aspect put on. So what Aspect put in the chat because he is on fire over there. All right, guys. We're gonna go up to number 40 to give you guys a full final exam review. 40 questions worth, all in all. And so let's get to going there. All right. So we have in problem number 38. We're going to find the product, and notice that we have a quantity squared. We have a binomial squared. And what you should know is that anytime you have multiple terms within the parentheses, and we have 2 terms within this parentheses here, you must not distribute that exponent on the outside. You can only do that when you have 1 term within the parentheses, aka a monomial raised to a power is the only time you can distribute that exponent on the outside. outside. And since that is not the case, you need to expand this. Okay. So once again, guys, please share the live stream with the people that you know and love, with the people that you know and hate. Go ahead, distribute that out to them. Like the video, subscribe to the YouTube channel Forbidden Tutoring. Click that bell notification so you could be identified. You'll get a notification when we are live. And as always, thank you, Angry Hermit, with a good stream. Appreciate that. And always, if you're able, please donate, as that helps us in our endeavors of educating the world for free. All right. And that includes you guys in the live stream. All right. And I am so happy, guys, that I finally figured out how to include you guys in a live chat on the screen at the same time, because I bet you half the world was wondering whether or not I was talking to myself the whole time. So now y'all know that there are real people talking to me while I'm doing this. And you better know, guys, that we are going to get our arrows popping on this problem. That's right. Get your arrows popping, and get your arrows popping t-shirt, guys, by going to forbiddentutoring.spreadshirt.com. The link is in the description box. That's right. Angry Hermit says free math videos with the sass included. You better believe it, Angry Hermit. I'm going to be sassy. I got that sass. We have 4x times 4x. That gives you 16x squared. We have 4x times negative 5y. That gives you negative 20xy. I like to put my variables in alphabetical order. It helps me identify my like terms much faster than if I would have just done it willy-nilly. Then we have the negative 5y times 4x. That gives you negative 20xy. Notice that I'm putting my variables in alphabetical order again. And then I have negative 5y times negative 5y. That gives me a positive 25y squared. And now we will be combining our middle terms here. So we end up with 16x squared minus 40xy plus 25y squared. And this... That's right, Jamila. We had to pop those arrows, and we have our answer right here, and we will put it in a red box. That's right. Aspect says, I'm going to destroy that final exam on Tuesday and make it to college algebra. Absolutely, Aspect. Absolutely, sir. That was problem number 38. Let's move on to problem number 39, guys. Moving on to problem number 39. Chosen Creeper says the problem's evil plan has been foiled. That is hilarious, Chosen Creeper. Chosen Creeper, you are on fire, sir. Mosby is in the house. What's going on? Good stuff, guys. Good stuff. Angry Hermit, I mean, come on now. You got to give it to Chosen Creeper. Let him make it. So here we have problem number 39. It says, find the sum of the solutions of the quadratic equations. And in this case, we'll make this quadratic equation. There's only one. Let's fix that. Yeah, see, let's take care of our grammar here. Speak correct English. All right, so here we go. Find the sum of the solutions of the quadratic equation. So not only are they asking us to solve the equation, we need to add the answers together. All right, so that's why I put this problem on here, so you guys are aware to make sure that you are reading the directions for each question. They are asking you to do something after you solve this equation here. All right. So there you guys are. You need to make sure that you're reading the directions for each and every problem to make sure that you're literally answering the question at hand. All right. So what we have here is the 5x squared plus 3x minus 2 equals 0. We have an opportunity to factor this problem. All right. And it looks like a problem that we had earlier today, too, by the way, I think. All right. So that wasn't done on purpose. We'll go ahead and solve it anyway, though. So if you were to multiply, let's go ahead and rewrite it. We have 5x squared plus 3x. I hate the 3. I hate the 3. I hate the 3. All right, plus 3x minus 2 equals 0. If you use the AC method here and you multiply the first times the last, you'll get 10, right? We know that factors of 10 are 1 times 10 and 2 times 5. We're looking for two factors of 10 that will subtract to give us 3. That'll be 2 and the 5, right? Okay, so that means that I'll be opening up two sets of parentheses. And with that, I have my variable x. I have 5. I have 2. The sign of the middle term must be the sign of my largest factor. That means that the 5 must be positive. And since I'm subtracting, okay, that means that I need to have the opposite sign on my number 2, the other factor. From there, because we had a leading coefficient of 5, we're going to be dividing both of these values by 5 and simplifying. That'll give us x plus 1 times this denominator will go in front of the variable to give us 5x minus 2, which equals to 0. And this is what we have so far. Now we'll be setting each factor using the zero factor property, set it equal to 0, and then solve for it. So our first equation will be x plus 1 equals 0. Our second equation will be 5x minus 2 equal to 0. And then we'll be solving for each equation. So in the first one, after subtracting 1 to both sides, you'll end up with x equals to negative 1. And for the second equation, we'll be adding 2 to both sides of the equal sign. And you'll end up with 5x equals 2, and then dividing both sides by 5. You'll find that you have another solution that equals 2/5. So your question here asks you to do the following. It asks you to add your results, add the solutions, find the sum of the solutions of the quadratic equation. So that means I have negative 1 plus 2/5. Well, I'll need to get a common denominator here. We can rewrite the negative 1 as negative 5/5, right? So I have negative 5/5 plus 2/5, and so our end result here will be negative 3/5 as the answer to this problem, and you better believe I'm going to red box it. So the bottom line, the main point of problem number 39 is to make sure that you're keeping aware of the question that they're asking you to do. So it wasn't just good enough to solve the equation here. That's not what they wanted. They wanted the sum of the solutions. So once you found the solutions, which in this case was the negative 1 and the 2/5, we had to add those together to get our final answer of negative 3/5. So make sure, especially during an exam, especially a standardized exam, they will ask you questions that sometimes you can't predict. So it's not enough just to look at the problem and assume what they want to give you. All right. So make sure you're answering the questions and making sure that you're reading the questions in the first place so you can know what you're doing. Okay. All right. So let's keep this party rolling, guys. Let's keep this party rolling with problem number 40. And I will ask you guys again to please share the stream with the people that you love and hate. Go ahead and like the stream. Not the scream. Don't scream at the stream. There you go. But like the stream. There you go. Comment. Subscribe to the YouTube channel for Been Tutoring. Mr. Witt is in the house with FBT. There you go, guys. All right, we have problem number 40. It asks us to factor negative x squared minus 2x plus 24. And when you are factoring, guys, what you want to do is you want to always factor out a negative something if the first term is negative. So in this case, because my first term is negative, I'm going to factor out a negative something. All right. So we'll end up with x squared plus 2x minus 24. All right. Aspect says we have to make sure we do not confuse quadratic equations with a question that is asking for the quadratic formula. Yes and no, Aspect. In most quadratic equations, as a matter of fact, in all quadratic equations, you can use the quadratic formula to solve it. For instance, in that previous problem, we could have used the quadratic formula to come up with the solutions. But even in that case, the solutions were not good enough. They wanted us to add those solutions together. So you can use the quadratic formula even in our previous problem. It's just that I have a personal preference of factoring and using the zero factor property if I'm able to. If that last equation was not factorable, I would have had to use either completing the square or the quadratic formula. But great question, Aspect, as always. All right, so we started out with our GCF of negative 1. Remember I said if the first term is negative, factor out a negative something, even if it's negative 1. So I'm showing that I'm factoring out a negative here. And now I'll be attempting to factor the quadratic expression that remains, the quadratic trinomial that remains. So I'll be bringing down my negative here. I'm going to open up two sets of parentheses here, recognizing that my last value in this quadratic trinomial is 24, and that the factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And I'm looking for two factors of 24 that will subtract to give me 2. So the two factors of 24 that'll subtract to give me 2, guys, are 6 and 4. 6 and 4. So we'll open up those two sets of parentheses there. Don't forget that GCF. Make sure you're bringing that down each time there, okay? And we'll have our variable x. we'll have the quantity 6 and 4. All right, let's fix this. 6 and 4. And we'll go ahead and lead with the sign of the middle term. So that largest factor must be positive, that the 4 must be negative, and this completes the problem, guys. We're going to red box this. And since you guys have been so good to me today, and since Polly King went ahead and dropped that $5 donation, I'm going to go ahead and do one more problem for you guys for your final exam review. All right, and let's do this one. Problem number 41. With problem 41, it says to factor by grouping, guys. So you get a bonus question because Polly King put it down on the donation, guys. Factor by grouping. Anytime you have 4 terms, guys, you can use the factoring method, or you can attempt to use the factoring method, factoring by grouping. There is a video for that Angry Hermit can put the link in for you guys, factoring by grouping. And what you want to do is, once you have your polynomial in descending order of your variable x, as we have it here, go ahead and group the first 2 terms together. So we'll be grouping x cubed plus 6x squared. You will always put a plus sign in the middle, even if the third term is negative. Even if the third term is negative, always put a plus sign in the middle. And you'll group the last 2 terms, okay? Your goal here, or your ideal here, is to make sure that at least one of these groups has something in common other than 1. And both cases, all right, both groups have a GCF that's not 1, all right? So we're good to go here. But if you didn't, you want to have at least one of these groups have something in common other than 1, all right, for the factoring by grouping to have a chance to work. So out of the first group, the GCF of those first 2 terms is x squared. That leaves us with x plus 6. Then out of the second group, we can factor out an 8. That also leaves you with x plus 6. And it's because you have 2 terms now. Remember that terms are separated by plus or minus signs, and they both have an x plus 6 in common. We can factor out that GCF of x plus 6. That leaves you with the quantity x squared plus 8. And this is the factorization of problem number 41. And we are going to red box it. All right, ladies and gentlemen. Well, that's going to do it for our final exam review for intermediate algebra. Thank you so much for chiming in with us today. As always, please rate, comment, and subscribe. Thank everybody that joined us in the chat today. I appreciate you guys. We got Chosen Creeper, we got Mosby Steve, we got Jamila, we got Louis Diaz, we got Angry Hermit, of course. Aspect was in the house. We have Obina in the house. We got Polly King donated today. We got Obina. We have Aaron Sharma in the house. That's right. We got Tehei Nana. We got that person in the house. What's going on? Tehei. We got Dan in the house. We had John Smith in the house. We had Jenny. We also had Fantasy. We also had, let's see here. We had Fantasy. We had Jamila. We had K Mills in the house. That's right. And let's see, make sure I got my last student here. We got Saran in the house. There we go with Jenny. We got Jess. We got Alexis in the house. There we go. We got Kate Boudreaux and all of you that chimed in and joined us for today's stream. As always, I appreciate you chiming in. And next week, guys, we will have next week college algebra final exam review live with Mr. Witt. So make sure you checking in on that college algebra, guys. The final exam review is going to be in full effect. So catch it live by clicking that bell notification. Go ahead and grab your t-shirt at forbiddentutoring.spreadshirt.com. The link is in the box, in the description box. We got Jenny saying thanks. I appreciate you, Jenny. It's all good. You immortalized on that super chat there on the stream now. Appreciate you chiming in. And next time, Trojan Creeper says that they'll catch up next time with a piece of paper. That's what it's all about. Lewis had that right answer. That's what's going on. All right. And we have our answer in a red box. Peace, guys. Much love to you.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT.